The concept for ePartrade is basically, in my opinion, there's a big hole in the internet. So the internet started many years ago, but there's never been an online business community for racers on the World Wide Web. The need for ePartrade is actually quite obvious. Basically, people in the business of auto racing need a place online to hang out and get their problems solved.
It's extremely simple for a buyer or for a supplier to interact on the platform. The first thing you need to do is sign in, which is free. And the second thing is, when you see a product that you're interested in, all you need to do is click on request more information. If it's a company, you click on request more information, and then from there, it is forwarded directly to the buyer or to the supplier.
You can go to ePartrade.com, you become part of a community of businesses in racing, and it makes sourcing products much easier than just on the internet or using Google.
At ePartrade, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier through an email.
More than that, it's a place to go just to keep current every day. So it's a good place to start your workday in your racing business or in your offices of your professional race team. And you know you're current when it comes to new technology, industry news, technical papers, technical videos, all of that and more. We're not looking for a million hits per day. All we want is people who are really the volume buyers of racing products in the racing industry to be part of the little world of ePartrade. We have racing businesses participating from around the world. So you get suppliers from around the world, you get buyers from around the world.
ePartrade really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Good morning from California, and welcome to Race Industry Now, the technical and business webinar series from ePartrade, presented to you by ARP. I am Francisque Savignan, the founder and CEO of ePartrade, the global platform for the performance and racing industry. This is episode 212, and we're going to travel to the UK to talk about sensors with a brilliant company called Elite Sensors. And two of my good friends are going to be presenting today. And I've known Clive and Bob for many, many, many years, and they're absolute experts in this field. So we're delighted to have them with us today. So with me this morning are Judy King, the co-founder of ePartrade, and our wonderful host, Mr. Brad Gilly. Judy?
Thank you, Francisque. I just want to take a moment and share that we've got a lot of upgrades coming on to the platform, and one was launched yesterday where we've got hundreds of logos of our upgraded suppliers scrolling by. It was a good idea just for additional exposure for all our companies, suppliers that are jumping on board. So, and there's more to come on that. So off to you, Brad.
All right. Well, thank you very much. Looking forward to this one for sure, and absolutely enjoying what we get to do here on Wednesday. So I think we're going to have a very fun one. Today's topic: sensors for motorsport by Elite Sensors, and it looks like we're getting them up right now. So I'll introduce our guest, and I'll tell you what, each one of you can maybe raise your hand as we get to each one of you. But Luke Lambert is the head of electronics development. We also have Bob McDonald, the chief technical officer, and
so Bob is currently unwell. So our CEO Mark Booker is standing in for Bob today.
Oh, well, very nice, Mark. Welcome. We appreciate that. And Clive Hill, chief engineer.
That's me. Hello.
And please help me make sure I pronounce your last name right. Sarah Scovena, is that right?
Yes, right. Hello.
Oh, wonderful. And she is business development with Elite Sensors. So welcome, everybody. And Mark, I'll tell you what, then I'll just start with you. Give us an overview of exactly what Elite Sensors is and what Elite Sensors does. And I know you guys have a slideshow and a presentation and everything, and we'll certainly talk about a lot of the different products and what you offer to motorsport as well.
Okay, perfect. So we'll share our slideshow, and I will talk through that and then pass on to Clive and to Luke as we go.
Wonderful.
Okay, so Elite Sensors Limited. Welcome to everyone. And firstly, can I say thank you to ePartrade for hosting today. It's very, very Happy to attend and to share Elite Sensors and the journey which we've been on for the last year. I am Mark Booker. I'm standing in for Bob McDonald, who's our CTO, who isn't feeling too well today. I'm joined by Sarah, who's actually based in Italy and who's in charge of our business development. I'm also joined by Clive Hill, who is our chief engineer, and Luke Lambert, who's the head of our electronic design activity. So, Elite Sensors, who are we? We formed our company back in November of 2019. We moved into the premises, which you can see on the slide in front of you, in March last year. So we've been in our premises for just over a year. We've got around about 3,000 square foot of office and manufacturing. It's a two-story building. Upstairs, we have our design and administration team. And downstairs, we have our manufacturing activity where we build, test, and ship all of our products. We're based in a place called Farnham in the United Kingdom. We are just south of London. So that's where we are, and that's who we are. We are currently a team of 6 people within the organization. Within those 6 people, we have over 135 years worth of motorsport experience. That motorsport experience comes from manufacturing. So our test technician and build technician has over 23 years worth of experience in building sensors. I have been in motorsport for over 30 years. Bob McDonald has been in motorsport over 30 years. So we're all very, very seasoned professionals within the motorsport business. I'm often asked, why did you set up ESL? So Bob and I set ESL up, to say 2019, because we're passionate about what we do. As a team, we're passionate about the quality of products which we design. We're passionate about the quality of products which we deliver. Most importantly, we deliver on time when we say we're going to deliver. We understand that there is a race event which will happen every weekend. That checkered start flag will go down at 2 o'clock on a Sunday afternoon. We have to be there. Our quality products have to be on the cars, on the motorbikes, and they have to last. Now, we've all been in situations where you're up against deadlines. Those deadlines have to be fulfilled. So we're passionate about that. We're passionate about everything which we do. Number one, we're passionate about our customers. Customers are the reason we're here. No other reason. Without customers, we're not a business. So we design and manufacture sensors, interface units, cameras, all within our premises here. We have a channel partner called Druck, who are part of the Baker Hughes organization, and we source pressure sensors from them for motorsport. So we are their channel partner into motorsport. Each part which we sell is uniquely serialized. Each serialized product has its own traceability all the way back to the raw parts which we purchase from our suppliers. So in 5 years' time, we can actually go back and say, okay, this sensor which was built 5 years ago, we can know who built it, who tested it, and exactly what part was used in the manufacture. And that's all encompassed within our ERP system. During the last year, since we moved in March, we have designed and manufactured 18 different types of sensors, and Clive will come on to that a little bit later. Within those 18 sensors, we have manufactured over 50 different variants of those sensors. That is one different design for every week that we've been in the office and we've been working. So the guys have worked phenomenally hard. Again, it's all down to the customers. Customers demand sensors which are unique to their installation, and we're here to fulfill that. So I'd like to hand over to Clive now, who can actually go into some of the sensors which we actually manufacture and design here. Clive.
Thanks, Mark, and good morning, everyone. So first question is, why is there a need to have motorsport-specific sensors? So anyone in motorsport knows there's a very demanding environment. It's very different to automotive. So the requirements for the products to survive have to be very different. So I'll give you an example. So the mechanical integrity of a sensor. So an OEM sensor might have a molded housing. And so wouldn't really be that structurally strong in a high vibration environment. In motorsport, you've got engine RPMs much higher than normal automotive. The suspension's much harder, so the levels of vibration far exceed that of an normal OEM sensor. Then there's the EMC considerations. So on a race car, you've got ignition noise, you've got driver radios, you've got telemetry, more recently now hybrid systems, all creating a lot of electromagnetic noise. And so our sensors have to be resilient to that, so we don't have corrupt signals and noise on our signal lines. Also the operating temperatures. Obviously we have clutch temperatures, brake temperatures far exceeding that of automotive, with some of the sort of carbon ceramic brakes that are used. So normal automotive sensors might be only rated to 85 degrees C. We have sensors that have to operate at 150 degrees C, 175 degrees C, and more recently we've done sensors operating up to 300 degrees C. The other thing is security. So we work quite closely with a lot of the governing bodies of the various race series. And what's really important is where you have control sensors, you need to guarantee that teams aren't trying to gain an advantage by trying to manipulate data to gain an advantage, and then present the data so that it all looks quite normal. So there's a certain level of security that has to be embedded within the product. The next point is high performance. So really high accuracy is required. And that's obviously so that you can trust the data that you're getting. And also, that's not just live and control data. When you're using that data later on and post-processing that and feeding that data that you've acquired back into your vehicle model for your simulation, you need to know that your simulation will then translate back onto the car on the track. Because if you're just putting bad data in your simulated model, you're going to have no correlation between your simulated model and what the car's actually doing on the track. So it's really important to have good data. Also, data rate. It's really important to have fast data. We sample really quickly, gear changes are in milliseconds. So it's really important that the sensor can sample quickly and process that data. The next point being fit for purpose as well. So our ethos is the sensor should be designed to suit the application and not the application to suit the sensor. So we have sensors whereby the same sensor could be used in the same application across multiple different customers. However, the sensor looks different every time because every team has their own unique installation. They want to optimize the installation. So we have to design bespoke sensors to fit into that so they can really optimize and be efficient with how they package the installation. Material selection as well. I mentioned earlier about high vibration, but there's other considerations as well. Temperatures, often where we're working in very hot environments. And also, if you're designing a temperature sensor and you want a really fast dynamic response, you have to also consider the thermal conductivity of the housing material. So there's strength, vibration, all of these other things as well. And I mentioned EMC, so as well, we make most of our sensors either have aluminium housings, titanium or steel housings. So what that does in terms of EMC protection, you can create a Faraday cage, which again protects the integrity of the signal. Final point is quality. So I think Mark mentioned earlier, we have an ERP system within our business, and that allows us to have traceability from raw materials right the way through to the finished product. It also handles all of our purchasing as well. Mark also mentioned that we manufacture all parts and we test 100% all of the parts that we make, just so that we have confidence and give the customer confidence that everything they get from us works to specification. And next point on quality is our assembly technicians are trained to IPC 610. And just to elaborate on that, what that means is it's a soldering standard so that all industries have different levels of solder requirements. And what we insist on is we have this IPC 610 specifies what we would deem to be a good joint. And so we inspect all of our hand joints 100% under a microscope to say that, yeah, we have absolute confidence. We take images so that we've always got these images so we can look back on them in the future if there's any question over the sensor's performance. Okay, I'm going to hand you back to Mark now, and he's just going to give a brief overview of where we're currently supplying our sensors into which race series. Thank you.
Thank you, Clive. So yeah, we're a year into our manufacturing and design. I'm very, very pleased to say that in Formula One, our sensors have been running this year. MotoGP, we've got sensors on the bikes. Moto3, again, we've got sensors on the bike. So in 3 of the large series in the world, our sensors are already out there and are being raced. We had a lot of validation during last year. Obviously, you know, within Formula One MotoGP, teams want to ensure that our products are fit for purpose. So we went through a lot of validation on dynos, track testing, etc. last year, and being raced this year. We've also got parts being sold out in Japan. We have a Japanese distributor. We've supplied parts into NASCAR teams, into WEC, Super GT and Super Formula, as well as WRC. So our parts are being used in most of the very large race series in the world, which is very, very good. We have, as I said, a European distributor. We have a Japanese distributor. And we're in discussions with various companies regarding the US distribution. So some of the teams we're dealing directly with, and we're happy to deal direct, but we understand you need a local presence. And so that's why we have the Japanese distributor, and that's why we will have a US distributor as well. We have also supplied parts outside of motorsport. So we're very happy to confirm, you know, we've got parts which are being used on an automotive car, supercar, and also for UAV application. So, you know, it's not just motorsport which we're concentrating on. We're looking at other industries where the leading edge, high performance, unique sensors are required. So, you know, we've got various customers throughout the world, various applications, and you know, we are looking to extend more. So, you know, some of the discussions we have outside of motorsport are very, very interesting, very interesting. So, you know, if there's any applications where you feel that you need this kind of sensor technology or interface units or cameras, please get in touch. So I'll pass across again. Thank you.
Thanks, Mark. So I'm going to give a brief overview now of the product range that we have to date. So as Mark said, in the last year, we've been quite busy developing a range of products which sort of cross over between engine sensors and chassis sensors and interface units. So I'll just take you through what we have now. This is constantly evolving and growing. We very much listen to what our customers say they need to help them develop their cars. So on engine sensors, so crank and cam speed. So for crank, I mean, ultimately the crank sensor is the most important sensor on the car. Without that, if that fails, then you stop racing. So it's the quality of that is absolute paramount. So our crank sensor is based on some people call inductive. It's a variable reluctance technology. It's a passive sensor with an iron core. It's a very well defined and explored technology. An iron core, a winding, a bias magnet. You get an AC voltage which goes directly into your ECU and allows you to do your crank timing and speed. And some ECUs can take the same signal in for cam speed as well. But for those ECUs that don't support that, we offer something, a Hall effect device. I have various props of sensors I can show you, but they're quite small to see. So this is a typical cam speed sensor. That's a Hall effect. Again, aluminium housing has to be very robust. Moving on to pressure sensors, as Mark mentioned, we have partnered with Druck in the UK. They've been established for many years, developing and manufacturing sensors for motorsports, subsea, aerospace. So they have very well defined products. So their pressure sensor is an analog sensor. So here's an example of this. It's a threaded part which can screw directly onto a pressure manifold. They make their own silicon on site. So the concept is it's a silicon diaphragm with a Wheatstone bridge. So when you exert pressure onto that diaphragm, it changes the resistance of the bridge resistors. In front of that, there is a stainless steel diaphragm. And then the gap between that is what we call is an isolation area, and that's filled with oil. So the idea is that you can use these sensors with all kind of corrosive media, fuels, oils, and what have you. And the corrosive media acts on the stainless steel, so it doesn't actually touch the silicon. So the stainless steel diaphragm deflects, transmitting the pressure through the oil and onto the silicon. And then behind this, you have the amplifier, which gives you a nice 0 to 5 volt analog signal. So those are used for oil, water, fuel, anywhere on the car. So, you know, pressures from 1.6 bar up to 600 bar when you're talking about fuel rail pressures. The temperature sensors, so on the engine, there are, you know, oil, water, fuel. So we tend to use this as a small threaded part. So this is what we call an RTD device, which stands for resistance temperature detector. So the sensor itself has a very well-defined characteristic of changing resistance with temperature. And we can use that characteristic to define the temperature it's measuring. So we do very many versions of this, and this is, you know, we do them with different threads, different lengths, different housing materials, all depending on the application. Also in temperature, we do thermocouples for the really high temperatures, so like exhaust gas. So we're talking up around 1200 degrees C, so really hot. So there's special materials there, the Inconels on the tips, things like this, so that they can survive the really harsh temperatures. The next point on there, throttle position. So again, a control sensor, really important sensor. Historically, this was always done using a conventional potentiometer. So had a conductive plastic track with what we call a wiper, which then rotates around the track. And for the change in angle, you would get a corresponding change in resistance. So that was, you know, technology that was used for many years. On a race car where you've got really high levels of vibration, what would happen is the shaft bearing would start wearing after a while. The fingers that touched on the track would start to wear the track. So it had a really limited life. So for us, we wanted to go completely non-contact. So non-contact means no wear whatsoever. So we got away with all these contact devices, no bearings. So we have a sensor. So it's a Hall effect technology. So there's an example of this sensor. So this would be mounted, and then in the throttle itself, you would have a small actuator magnet, which would rotate in front of the sensor. Now, the Hall effect principle, as the sensor rotates, the sensor detects the change in the magnetic field direction, and it converts that into an analog 0 to 5 volt output. Moving on to chassis sensors. So here's an example of a 3-axis accelerometer. So this is something is used to measure vehicle dynamics. Again, so you feed that back into your model for developing your car further back at the factory. So this would normally sit under the driver's seat. We do versions of this. So we have hub accelerometers, which is a single axis part, which you would put on each corner of the car. Has to operate at higher temperatures, so it's rated up to 150 degrees C, because you have all those hot temperatures radiated from the brake pads and the brake discs. And then we have another sensor 3-axis part, which is for vibration analysis. So really high G, up to 2000 G, high frequency, you know, we're talking up to 15 kilohertz. So that's where you're doing vibration analysis. If you're really trying to home in, if there's a problem somewhere, you can stick one of these on and identify, you know, what sort of loads and forces you're putting on that particular area of the car. So also on the chassis, temperature sensors, again, very similar to the engine ones. We have air ones as well. With those type, very similar, but we would have an exposed tip where air flows through it. So you've got a faster dynamic response. We also do brake temperature sensors. So here's an example of a very small brake temperature sensor we did for a caliper, just screws onto the caliper. This particular one has to operate up to 300 degrees centigrade. So yeah, that's some very specialist materials in there. We had to go away from the conventional materials we would use in PCBs and what have you, and use some quite specialist materials there. So we do temperature sensors for some quite specialist applications as well, whereas that one was a very hot up to 300. We're currently working on a project which actually requires sensors to operate down to -100, which is quite a unique, again, changing materials, changing solders, all of these different things that we've kind of used for standard products all has to go out the window, and we have to look at quite alternative materials and processes. Other chassis sensors, so rotary position, so again, a bit like the throttle sensor, we use these or supply these for gearbox control. So very same again, non-contact sensor, also for steering, suspension, based on this Hall effect principle. We also have a range of linear sensors. So for short stroke, we've again gone away from conventional contact sensors because of the wear, and we use a Hall effect principle again. So we can do short strokes for suspension, brake master cylinder. The beauty of this technology is you can actually you can remotely sense. So if you can imagine a brake master cylinder where you've got a pressurized cylinder, and you can't get a sensor inside of that because it's pressurized. So, but if you can mount a sensor inside the piston, mount a magnet inside the piston, and then a sensor with a lead outside of the pressurized area, it can see through the aluminium body of the master cylinder, and it can detect a range of linear motion. So it's quite a neat solution for that. Again, pressure sensors on the chassis, again, the normal things, fuel, oil, hydraulic fluids, those sorts of things. Gearbox shaft speed, so input and output shaft on the gearbox. So this is a speed sensor that has to work down to 0 hertz and then up to sort of 15 kilohertz. So in Formula One, for example, they use these sensors to also detect or to derive position. So they're not only measuring speed of the shaft, but they can derive position. So if you mount two sensors on a shaft, looking at the shaft, and they are orientated a specific pitch apart, then you can actually derive the position from that. And the reason they do that is for seamless shift on gearboxes. So in Formula One, so whereby they're trying to avoid the dog-to-dog collisions that they often get on shifts. They want to shift first time. They don't want to have this dog collision, which means they have to retry the shift, which loses time. So if they can actually know the position, they know when to change the gear. So that allows them to do that. So it's all about gaining advantages. And then finally, our wheel speed sensor. So this is differential Hall effect principle. So the purpose of this is an example. This is quite a large one for a specific application, but they can be made as small as this. So the differential Hall effect, the benefits of differential are you get a much stronger signal. You can work at larger air gaps. You have no signal noise. The sensor operates up to 175 degrees C. So it's a really forgiving sensor in quite a harsh area on the car. We also have a range of interface units. So this is the one that's on the picture on the slideshow, just gives you a bit of more perspective of scale. So the purpose of an interface unit really is to gives you more I/O on the car. So if you've run out of inputs on your data logger or on your ECU, then you can add one of these, and so suddenly it opens up, it unlocks more I/O connections. So you say, I want to add more pressure sensors or temperature sensors, then you can add one of these. The other thing it does, it rationalizes your harnessing slightly as well. So if you've got lots of analog sensors you want to put on, and then all of these signals go into this box, but the outputs come out over CAN. So you might have 16 inputs going into this, but the outputs come out over just CAN. So you've got CAN high and low, and that's across all of the sensors. So it makes your harnessing much simpler, much more lightweight. We also use these for LVDT, so linear variable differential transformers, so position sensors ultimately. So this will drive the LVDT, and it will get the signal back and transfer that analog output over CAN. We've got thermocouple interfaces. So often on test, people want to instrument the car, put lots of thermocouples maybe across a wing or close to an exhaust. But again, might be limited by how many inputs they have on their logger. So we can fit one of these, and then it suddenly opens up the amount they can fit. We do combined units, which have a range of speed inputs, analog inputs, temperature inputs, thermocouple inputs as well. We also have single channel interface units. So again, where people might want to have a P2000 temperature sensor and they just don't have the inputs, but they have 0 to 5 volt inputs on their logger. So this little inline interface allows them to do that. And the same with the thermocouple, we can do that also. The last one on there, hydrogen sensors, we're developing and exploring due to the increased use of sustainable fuels, really. So this is something that we are sensing more of. It's been much more popular now. So looking at hydrogen detection, being such a volatile gas, then you need to be able to detect leaks to operate safely. So we're looking at detecting sensors. And then temperature as well, being it's so volatile, you really need to keep it in a safe environment. So measuring the temperature, but with hydrogen, in terms of how you manage it, the gas is very hard to seal. It causes embrittlement in certain materials. So we've had to do a lot of work looking into materials and how we can actually plug these sensors in and not compromise the system. So it's been quite a development area for us. Okay, well, thank you for that. I'm going to hand over to Luke now, who's going to talk about a couple of our newly featured products, and yeah, starting with the thermal camera. Thanks, Luke.
Thanks, Clive. As Clive said, I'm going to try and talk through a couple of our new products, starting with our radiometric thermal camera and inbuilt logging unit. It's a thermal camera with a 90-degree by 70-degree field of view, and has an image which is 120 pixels wide by 84 pixels deep, providing you a temperature measurement for each pixel, giving you 10,080 temperature measurements per frame. As I said, it's a standalone unit. It doesn't require any supporting units, and it has the logging built in. We've designed it with motorsport in mind, and it's designed to be fitted to a car rather than used in a laboratory environment. So it's small, it's lightweight. I've got one here, so again, it's quite hard to see, but it's got a motorsport connector on the back and a protective window on the front. So if you want to fit it in a place that's likely to get gravel spread, you can replace the window. You don't have to replace the whole sensor. And the windows are available and interchangeable if you want to. As I said, it's designed for motorsport, so it's fully configurable over CAN. You don't need any special software or bespoke interfaces. It can be configured on the car or in the lab or in the garage. It's designed with two main functions in mind. You've got the live function, where you would use the camera with the CAN output. So you can configure 32 temperature measurement points within the full array, and they will be output over CAN. You can configure those using CAN. So you define a sort of an X and a Y value, and you choose your pixel you're after. You can do that for all 32 points, and then you can measure that on the car. And they're available in a selectable transmission rate as well. So you can configure the transmission to be between 0.2 Hertz and 10 Hertz. As I said, everything is configured over CAN, so all of the logging features are also configured over CAN. The unit's sort of second purpose is for post-processing. So as I said, it's got internal logging, so all of the frame is logged, not just the 32 pixels. So you have 10,000 plus temperature measurements for every frame. The unit has a total logging capacity of 64 gigabytes, and that would provide you with a total running time of over 24 hours at the full logging rate, so more than enough for most events. Also configurable is the file name structure for the logged file, and you can synchronize it with the rest of the systems in your vehicle as well. So you can send it a time in milliseconds and a date, and then the file will be timestamped according to that. And along those lines, we were very aware that you need to be able to synchronize data from multiple systems on the car. And so we have a digital input that you can pull low at a specific time, and it will start a new session within the files. at that point in time. So that might be every lap you decide, okay, I want to start a new session, and then I can synchronize that with the rest of the data. Or it might be, I don't know, a specific event on a corner or something similar to that. And that can be done, as I say, with a digital input with no delay, or you can also do that over CAN, but sometimes you do have CAN delays involved in that. So once you've finished using it and you've got all of your log data, it needs to be offloaded. And to do that, you just plug in a USB, you plug it into the PC, and it would appear like a USB stick on a file. You can obviously drag that and drop that into your own location. And then we have a very simple piece of software that will enable you to either offload it and save it in a BDS format, which is a format that will allow you to use our graphical user interface for viewing the file, and I'll show you an example of that in a minute. Or you can offload it in a CSV format. With that format, it would enable you to import it into any analytics software that you might be using, and then compare it to other values that you're logging from other units. Okay, so we're now going to try and share a video, and I'll just talk through the different options in the GUI. So hopefully this will work. So we should see. We can't see anything yet. Okay, so here we can see a recording of the GUI that I did earlier. So it's just me at a desk moving around. You can click anywhere on the screen, and you'll be able to see the actual value in the bottom left-hand corner, and that changes as the picture moves. You can also draw a line across, as I've just done there, across my neck, and you can sort of see on the left-hand side how the background temperature is low, and then my neck is at a high temperature, and then it sort of goes low again. So that might be useful if you're monitoring a tire or something and you want to see how it changes over the course of a run. And I've done it again there across my shoulders, and you can see that it gets a bit wider. In this picture, you can see there's some lights in the ceiling. It's picked up those. And the GUI allows you to do some other stuff as well. So here you can see that you can flip it on the x-axis, you can flip it on the y-axis. You can speed the video up, you can slow the video down, and you can add filters, and there's a few other options as well. So that's just a sort of GUI that enables you to use the data that is logged on the camera in a graphical way. It may also help you to select your 32 points of interest if you're post-processing and you say, oh, that's a nice interesting point, and then next time you could have that logged live whilst running. So yeah, I'm just going to go back to sharing on here. Okay, so that's pretty much it for the thermal camera. I'll move on to our second. Maybe I'll move on. There we go. Now I'm just going to give you a quick overview of our next product, and that's a laser ride height sensor. Again, it's designed specifically with motorsport in mind. It's got an Autosport connector on the end, and on the underside there's a removable window again, so you can replace it if it's fitted in an area where it's likely to get hit with stones and you don't want the actual sensor to be damaged, and you can just replace the window. It's very small. It's only 46 millimeters by 30 millimeters, so it's a very compact unit. Again, lightweight, small is what we generally aim to achieve. It provides you with a 1 to 5 volt output, which is 12 bits. It's got good linearity and very good over temperature. One of the key features that we personally like about the sensor is that it has a 4 kilohertz output. So it's a very fast update rate, and where that might not be useful for the sort of traditional uses of the sensor, it could potentially be useful for other areas of development. The sensor comes with a few production configurable features, so it can be available in a 200 millimeter height or a 500 millimeter range. And there's a couple of averaging filters that can be applied. So we have the option of the standard, which is a median filter. The standard is a 9-point median filter, but it's available between 3 and 9. We do a moving average filter, which just takes an average over the previous number of samples up to 128. We do a recursive average, which is a kind of heavily filtered output. It operates a bit like a low pass filter, but it gives you it gets rid of any sort of big spikes that you're not really interested in. And then we also provide it with a raw output if you're just interested in the raw data. All of those filters or averages are done on a moving basis, so you don't lose the update rate. It just takes the next point plus the previous however many you've defined, and that keeps moving as you go along. And the averaging filters are definitely useful to sort of, because you've got a 4 kilohertz update rate, you don't want to be necessarily picking up all the different grains in the tarmac if you're just using it as a standard ride height sensor. Whereas, so this can kind of average those out and gives you a nicer signal depending on what you're after. So yeah, that's pretty much it in terms of sensors and the presentation. We're happy to answer any questions or go for anything of interest.
Oh, sure. That was amazing, wonderful, and thorough. I did want to ask you, perusing through the website, which is very extensive, and a lot of the stuff that we did get to see on the slide and some of the images is on there as well. But, you offer bespoke design. And for someone who might have a specific application that they want to come to you and say, hey, let's start to design this. What's the process involved in that one? What's the time frame?
So typically, we show standard products, but we know that very, very rarely people order the standard product, and so they'll come to us and say, we want, a wheel speed sensor, but we don't want it to look anything like this. So if it's a simple mechanical design, for example, new housing, it's going to look different shape, form factor, then we can normally manufacture parts within 4 weeks. So from agreeing a specification to having parts with a customer, usually 4 weeks is what we try and aim for.
Wow, that's pretty quick, actually, especially considering, a lot of the turnaround that people are looking for and all of that. There is a question from the chat, and maybe this is more of a greater sensor question, but we'll go ahead and ask it. It says, I recently improperly broke in a race engine, glazing the cylinder walls and causing oil to blow by. The O2 sensor carboned up, and other than a replacement, is there any way I can clean or restore it? Maybe this is even a broader question on, how to take care and maintain sensors. And I know a lot of race teams are pretty specific about, their breakdown and reassembly of race cars and making sure everything is taken care of. But how would you answer that?
Difficult with an O2 sensor, because they have an exposed sensing element, so oil on that is by its nature, it has to be exposed. So I would say that just some kind of trichloroethylene or something like that should be able to clean that sensor. But obviously every sensor's different. We're not familiar with that manufacturer's sensor, but something like that should still be resistant to a trichloroethylene or something like that can be used to clean it.
Here's another quick question that just came through. It says, hey, thanks for the presentation. How do you ensure accuracy of the radiometric temperature cameras? Is each calibrated?
Yes, so each camera is calibrated, and it's actually calibrated with the window on as well to avoid any extra losses and influences from that.
It's pretty fascinating when you were showing the camera too, and even talking about things like, monitoring tire temperatures or temperatures across the tire and different things like that. What really are a lot of the applications when it comes to that? What are people doing?
Some applications we know of are a tire is the obvious. Then there's, you might want to measure a heat exchanger, for example. So you can, because it's sort of designed to go on a car, it's easy to fit it in installation and then monitor the sort of heat exchanger. Or we've heard of people using them on external clutches, for example, so trying to find hotspots or whatever. Pretty much anything.
Cooling systems as well, as Luke was saying. So if you're trying to see in a radiator, if you've got any hotspots or anything like that, it's ideal for that.
You know, Mark, at the beginning, you talked about just the quality of the products and the traceability and everything like that. Could you speak a little bit more of that? Because obviously, you know, anytime someone has something go wrong, you know, they want to go back to the source effectively. But just really kind of how you do business, essentially, and the quality of the products and just how far you take that.
Yeah, sure. So, you know, I've been in motorsport 30 years now. First time something like this happened was back in the early 90s, where there was a batch failure of a part, and I got asked, where was this part used? And we didn't have the systems, we didn't have the ERP systems at that time, so introduced a own manual system. And that highlighted the fact that whatever happens, you need to be able to go back a serial number from 5 years ago, 10 years ago. If there's a batch related problem, you need to know where that component was used in every single batch. So every part which we purchase for our manufacturing has obviously a part number. It has our stock part number. It has a batch number associated with it. So I could go down to our stock now and I can tell you exactly, just from pulling apart from our stock, exactly what part it is, who it was purchased from, which year it was purchased, which week it come into the premises, and what day of the week. That's all contained within our batch number. That's then recorded on every manufacturing part which we manufacture. So in 10 years' time, if someone said to me, serial number 25, I can actually go back to our manufacturing instructions. I can tell you who built it, exactly which parts were used in that manufacture, who they came from, the delivery note from the supplier, which should contain all the information, who tested it, who shipped it, who inspected it. Because you need to be able to, you know, in my 30 years of motorsport, I've only ever had the situation 3 times where it's been a batch related problem. You know, you learn every time. And so the system which we set up from day one, so from March last year, we introduced a Sage ERP system, a Sage ERP 200 system, and that has that complete traceability. So everything from raising a quotation, the quotation goes automatically into a sales order, automatically into a manufacturing works order, which then gets controlled via our purchase orders, which then gets controlled via the works order, stock issue, etc., etc. So yeah, absolutely, it's 100% to make sure that from source, from our supplier, that in 5 years' time, because every single part is uniquely serialized, you don't even need to know what the part number is. Give me a serial number and I can tell you who manufactured it, who it was sold to, when it was sold, how many times it's been back for servicing, another important part. So we have complete service history. So every part which gets returned gets logged in on our system. So, you know, in a year's time, if there's a battery in a system, then we need to know that that battery is out of shelf life. And so we can actually go to our system and say, tell me every part where the battery needs replacing.
Wow, that sounds extensive. Another question from the chat. It says, please comment on sensor noise immunity. I know you referenced, you know, basically putting it in a Faraday cage, but mechanical, electrical, RF, magnetic interference, all of that. If you could comment a little bit about that.
Yeah, I mean, we put, I mean, Luke, being the hardware developer, puts a lot of filtering on the sensors as well. So sort of trying to filter out any noise. From a mechanical point of view, the way that we design them is such so we try to make them resilient to vibration. They all of our sensors tend to either have CAN or analog 0 to 5 volt outputs, which in itself is pretty noise immune. We're not talking, you know, we're not talking about millivolt outputs, which, you know, you can get noise superimposed on that really easily. So we try to, and you mentioned, yeah, the Faraday cage, trying to create a sensor housing which is going to shield from external noise. And if it needs a shield on the cable, depending where it goes, you know, if it's running down near an ignition line, then you shield the cable. So all of these sorts of things, it's about understanding the application and what we need to do to mitigate against noise.
Yeah, you also referenced basically alternative fuels, EVs, and hydrogen, and all of that. You know, really being on the leading edge of some of these new technologies, new things coming into motorsports. Could you comment a little further on that?
Yeah, I mean, it's something that's again being led by customers of ours. That the hydrogen was something that a customer is saying to us. You know, hydrogen fuels been, you know, explored much more frequently, and certainly in motorsport, it's a great place, sort of a testing ground, if you like. So it's opened our eyes to, you know, all of the material considerations, because we're only going to see more of it, more of these alternative fuels, more sustainable fuels. So we need to evolve and develop our product range to kind of cater for that. And, you know, with electric vehicles, the type of sensors that we'll be developing will have to tailor to that electric vehicle market. So it's very much, you know, as we see, you know, IC engines will be with us for some time for sure. So we know the sensor requirements there, but there's, you know, there's more and more traction and more movement to alternative fuels. So we really need to be moving with that.
And I think being in the motorsport industry, you know, everyone in the motorsport industry knows that you've got to move forward and you've got to run forward, because unless you're running forward, you're going to be left behind. You know, so that's what we're doing as a business as well. You know, yesterday is in the past. All we do is look forward.
Very well said. And a quick final question, you know, for anyone who might be watching this either live right now or back on the recorded, if they want to get in touch with Elite Sensors, if they want to, you know, talk about doing business, and I don't know if this is where Sarah comes into play or whatever it might be, what's the best way to contact you? What's the best way to get that process started?
So we've got a website, elitesensors.co.uk. That has all of our contact details. It has our telephone numbers. If anyone wants to call for a general discussion, we're always here. We have inquiries at Elite Sensors email address as well. So just get in touch, and you know, we've got engineers here who are happy to have those technical discussions, sales discussions. If you've got lead time issues, if you're, you know, up against a hard deadline, get in touch with us and we can discuss it. And you know, number one is that we are here to help our customers. As I said earlier, without customers, we're not a business, and we understand that. 100% focus on our customers.
No, a very impressive, without question, an educational presentation today. And we can't thank you all enough. Thank you so much.
Thanks, Brian.
Thank you, Brad.
Thank you very much for being with us today.
Thanks,
So,
Ross.
perfect presentation. This webinar has been recorded. It will be posted later on the ePartrade platform as well as our YouTube channel. We also pushed Elite Sensors product back on the homepage of ePartrade, so please take advantage of it. Thank you very much for being with us today. We will be back next week for something very different. We're going to be talking about history of motorsport with a gentleman called Ken Clapp, who was right there at the beginning of NASCAR and is still involved after 71 years in the business. So we're going to have a lot of great stories. And so thank you very much for being with us. Let's go racing, and we'll see you guys next week.
Thanks, guys.
Thank
Have
you
a good
very
day.
much. Thank you.
Bye-bye.
Thank you. Bye.
Registering on ePartrade is easy. Fill out your name, email, phone number, and create a secure password. Next, select your business type. Choose supplier if you're looking to display products or services and connect with buyers. Choose racing business if you're looking to find new parts and connect with suppliers. Choose race team if you own or are a member of a professional racing team. Begin typing your company name. We most likely already have your company in our database, which you can select from the drop-down. Then, enter your job title. Choose Claim Company if you'll be editing your company profile. Other members of your company can choose Join Company if they'd like to use ePartrade as well. You can view and agree to our terms of use here. If you'd like to receive our weekly newsletter, choose Accept. Click Register Now, and your registration will be submitted for approval. You'll need to confirm your email once it goes through. To keep our platform industry only, you'll be approved shortly after. If we require additional proof of business, we'll reach out. Welcome to ePartrade.